We have a new module. This is a relay module, 5 volts. Current of 10 ampere for 250 volts AC and 30 volts DC. If the current is 12 ampere, it is suitable for 125 volts AC or 28 volts DC. So for 250 or 220 volts, the current is 10 ampere. For 125 volts AC, 12 ampere. And this is 5 volts DC relay. It means the power of the relay is 5 volts. And we have the 2 LED. And then the pin header, some resistors. There is a transistor. And then the diode. So this is a transistor type relay. So the driver of the relay is transistor based on the components used. Also we have the terminal block for it's a Chinese. We don't have the label. HW307. Based on the drawing, that is the coil. Coil 1, coil 2. And then for the middle, we have the common. For normally closed, that is located here. And we're going to rotate the relay. If we rotate the relay, normally closed is here. And then the common, and then the normally open. Normally closed, based on the drawing, located here. And then the common, by tracing the PCB. Normally open, normally close, common, open. We have the figure 1 actual module relay. Same as here. We have the relay, terminal block, 2 LED, pin header, resistor, transistor, then diode. That is the actual module relay. After tracing the connection, we have now this schematic diagram from the actual module relay. So from actual tracing the connection or reverse engineering, we have now the schematic diagram. And also we have the pin out for the transistor. We are using 2 TY transistor in its package. 1 is the base, 2 is the emitter, 3 is the collector. It is a PNP type, PNP. And then we have the legend or the origin. The components 102, 102, 102. The transistor, the diode, switching diode, that is a pass switching diode, the LED, the relay, and the terminal block. So after the reverse engineering, we have this schematic diagram for this module. So we have the for the relay, why is it that the VCC is 5 volts? Why do we need to use 5 volts for this VCC 5 volts? Because our relay is 5 volts. The relay is 5 volts, that's why we're going to use 5 volts supply into the input or the control side. For this is the relay, this is the control side, and this one is the output side. So the red LED is the power indicator. And the green is the indicator that the relay is activated. We have this transistor PNP type QTY, which is also equivalent to S8850, S8550, S8550. The emitter of the transistor connected to the 5 volts. Then the base to the 1K to the input. So the input here, IN input connected is the resistor. And then to the collector, we have this output. Is connected to 1K and then the D3, the green LED. And to the collector connected is the diode. Fast switching diode 1N4148. Connected is the relay. So what kind of relay we are using here? Is this a high level triggering relay or low level? And besides, the relay is connected this way into the ground to the collector. What level? Is it low or high level triggering? It is low level. Low level triggering. Why is it low level triggering? Because we need to pull down to the ground this base so that it will function. We need, if there's a switch here, we need to pull it down to the ground or to ground so that the current flows into the emitter to the base, switching this transistor on to the base then to the ground. That is a typical flow of the PNP type transistor. Biasing this transistor by 1K, switching the emitter base 0.7 volts. In the case of silicon transistor, since you're putting a switch here to the ground, so it will pull down to the ground. That's why it is low level triggering or zero level. Because of that, the current flows also to the emitter to the collector, causing this LED to turn on green because there is now a current. So in electronics, sometimes they call it this part as sense resistor or sense component. This one, it sense the current. Sensing the current. Because there is a current here, it flows to the R3 and to D3, turning on this green LED. Because it is on, it will now cause the current to flow into the relay and then causing this coil to magnetize, turn into a magnet, and then the contact will move into the from pin number 5 to pin number 4 because it becomes now a magnet due to the induction of the current that flows into the coil. And once we release the switch, when we press and then release, there is no more current that flows into the collector. This contact will move again to pin number 5 And because of that, it will produce a back EMF or a voltage surge. And that's why there is a diode here to protect the circuit. Instead of flowing the current back to the transistor, it will flow somewhere here until all the current is until there is no current that flows into the loop, because it produces a high current into the circuit due to the back EMF or the switching on and off of this relay. On, off, on, off, on, off. The contact moves from 4 to 5, on, off, due to the switching or the pressing of the button. Okay? When we press it, it pulls down to the ground or low level. It means pulling to the ground or a zero level. Pull to the ground or as if there is a negative voltage that flows into the transistor. That is the current. And then it current flows here into the output and causing the relay to turn or to switch the contact, moving the contact from here to here. Remember that there is no connection between the two, the output side and the control side. There is no electrical connection. It is purely the magnet, the induction of the coil, causing it to become a magnet, magnetizing the contact, and it will go from here to there. So it's just like a wiper that clicks on and off. How about the high level? What is this high level triggering? High level triggering, it means we're going to, if this is the transistor, we're going to inject the transistor a push current. We need a push current, and then there's a relay here. The current flows into the transistor and to the ground. Or we need a high level or 1 or a signal 1. We are injecting a voltage to the transistor. But here we are pulling down the transistor to the ground. But here we are injecting the voltage if this is a high level type triggering. We are injecting a voltage or a high level 1 to the circuit, causing the relay to activate. But here we need to pull down. Remember that this is a transistor that serves as a switch or driver to the relay. So this transistor serves as a driver to the relay. If this is a transistor that drives the relay here, if this is high level, you need to inject a voltage to the transistor to activate the relay, then to the ground, to inject a voltage or high level 1. But here, low level, to pull down. Since we're using PNP type transistor, we need to pull down the base to the ground. That's why they call it low level, low, pulling down to the ground. High level, injecting a voltage to the transistor. This is now our new circuit, and we have two supply from the control side, one power bank, and the high side is another supply, power bank. So we have two supplies, power supplies. The blinking is caused by the power bank. Okay? And then when I press the button, it turns on the red LED. And you can hear the clicking sound of the relay. So when I press the button, it means I'm pulling it down to the ground, or this is a low level triggering, causing the other LED to turn on. You can see green LED, same with the green LED of the output. This red LED is connected to normally closed. and this green LED is connected to the normally open of the relay. We now go back to our circuit. So here, this is the control side and powered by power bank. Control side, and then this one is the output side or the high side, another power bank. So here we have these two LEDs, the red and the green, the output LED. The red is connected to the positive of the supply and then to the normally close of the relay, then come back to the supply. And then the green LED is connected to the positive resistor, green, and then to the normally open. So as I've said, the relay has no electrical connection between the output in the control side. It has no electrical connection, just the magnetic properties of this coil. So when we did not press the switch, when the switch is open, LED red turns on because there is a complete circuit into the output side. Negative, positive, resistor, red LED, and then to the normally closed terminal of the relay, then back to the negative. So there is continuous circuit or current supply. That's why output LED red turns on. And this green LED turns off because there is no circuit, complete circuit. This is the one that has a complete circuit because of the supply, the first supply of the power bank. And then once we pressing the switch, when we press the switch, so it will, as we have discussed before, it will trigger a low level triggering, pulls down the transistor to the ground. So there is now a transistor now switching on, causing the current to flow here. Green LED turns on and activating the relay. What happened to the relay? This contact will move into the position number 4 because it becomes now magnet. It magnetizes the contact. There is no electrical connection, just the magnet. When the current is passing to the coil, it will become a magnetic or through induction. So this contact now moves here from number 5 to number 4. Now there is now a complete circuit from this supply to the green LED and then back to the common, to the normally open common. And what happened to the red LED? It will turn off because the contact now is located into the pin number 4 and 3. So there is no complete circuit for the red LED. So it will turn off. And the complete circuit is now into the green LED due to the movement or moving the contact to the pin 4, 3, causing this a closed circuit. And because the relay is activated, we activate the relay. And of course, this green LED turns on because the transistors is turning on or switching on to the ground. And with this clamp diode, it will help to counter or to prevent a voltage spike into the circuit. Once we release the switch, it will go back to the pin number 5. So green LED now turns off and red LED turns on again because there is now a complete circuit to the red LED because the switch now is open and the relay is deactivated, and we have now this red LED that is turning on. So if we press it again, green LED turns on. Also the green LED into the output side or the high side. So this part is a control side. This one is the high side or the output side or the load side. We can use also a different voltage here. We can use 220 volts lamp. But due to the low level triggering of the transistor, it will cause the relay to activate. And then causing to a clicking sound is produced due to the movement of the contact from 4 to 5, 4 to 5, just like a wiper. 4 to 5, 4 to 5, and to combat the back EMF produced by the collapsing of the magnetic properties of this coil, we have this clamp diode. Okay,